I made a 3D product from waste PET bottles and turned them into PET filament. This is direct PET filament machine. PET stands for polyethylene terephthalate. Hello there, this is my journey to make PET filament and I hope you like it. For the past few years, I have watched many YouTube that make PET filament from trash bottles. Thanks to CNC Kitchen and JRT3D for the inspiration. Turning waste into treasure by using used plastic bottles and create 3D objects. This is my first version for making PET filament machine. I watched the tutorial on YouTube. This is his YouTube channel. I watched many steps. I chose the filament maker machine. There are several material needed to make PET maker filament, such as Arduino Mega, ramp 1.4, hotend and nozzle, stepper motor NEMA 17, driver A4988, and power supply 12 volt. Here the website that how use ramp 1.4. I give you the link in description. Now, let's make a hole in a nozzle, around 1.8 diameters. The original filament is around 1.75 millimeter. Unlike PET filament, the filament has holes similar to straws. Make sure you drill right size, otherwise the filament will be different. Like example, if the hole of the nozzle is too big, the filament is going to be hard to melt in printer, and if it is too small, the filament will be hard to come out in the nozzle and filament machine. This is an example of my nozzle. Watch the tutorial from Mr. 3DP. Look for a board for the base and make sure to get a thick board, otherwise the board will break due to the pulling force. Let's make a puller. You notice that my pullers are a bit different. That's because my stepper motor doesn't work, so I changed into DC motor. I found the puller from YouTube. He made the PET machine to call it Pentimenter. The design is very simple and saves filament. But there is a problem. I make a mistake about the motor DC. The DC motor that I have to buy must be high torque and low RPM, because it pulls the filament very hard. If not, then the device that controls the DC motor will be damaged because the DC motor is too high RPM. There is another problem using this puller. It's not strong to pull filament out from hotend. That's why I upgraded and made a new one. I shared the design in description. This puller turning speed into high torque by using 3 gears instead of 1. Let's make a piece of bottle strip. First, use the heat gun to make the bottle flat and cut the bottom of the bottle. Second, make a cutter. You can use a ring for spacing the stripes for bottles. Third, insert the bottom end of the bottle into the cutter. Pull until the bottle runs out. For bottle cuts, the thickness of my bottle is around 0.3, so my bottle width is 6.0. And if the bottle has a thickness of 0.2, then the width of the bottle is 8.0. But this only applies to bottles in my region, so do an experiment. If the filament is too big, the printer will jam and it will be difficult for the filament to melt. Worst case scenario, the filament will get stuck if you force it to pull. If the filament gets stuck, use the stick and plug it until it comes out. And if the filament is stuck in the nozzle, then use a soldering iron to melt the filament. This is my 3D object product which is half finished because my printer is jammed. You can see how thick the filament is after it enters the extruder. Around 1.75 or 1.8 millimeters. Let's make the filament. I forgot to tell you that use the LCD to control nozzle temperature. Here the finished filament. It takes around 1 hour for one bottle. Every bottle has different color, so you can make different color filament. Let's print it. Back then, I used my lab 3D printer for the test. And it works. The 3D printer name is Upbox. My first PET print filament was a small tube. It works perfectly. My second print was a cat. Not perfect, but I learned from it. The problem is that the filament is too big, so it can't melt. This is the setting for using PET filament. The temperature for the PET filament is 260 degrees and the board is 80 degrees. I use perf board. Back then, I did several experiments, such as changing the temperature to melt the filament. This is my final result of my filament machine, many changes and failures, but it is worth it. This was the problem that existed at that time. First, the stepper motor doesn't work. Second, the board is broken. Third, I got the wrong DC motor. Back then, I used my hand to pull the filament for 1 hour, and I have to buy another motor controller. Fourth, upgraded another puller. This is wasted of filament. Fifth, many filament fail, and this took for versions of my filament PET maker machine for perfect filament. Sixth, here the cost of making this machine, and here the list what material I buy. Note that my costs are a bit different because I buy the material around my area. This is just version 1. There are many upgrades and failures to tell, and I'm very sorry for the lack of documentation. I regret that time. And this is my first video content, but I learned it a lot. Thank you and goodbye.